So we're making measurements. We know that there's always some amount of uncertainty that's present in those measurements, and maybe we've quantified that. We've done multiple measurements. We've seen how much they vary. This is often quantified through a standard deviation, and we'll talk about some other possibilities, such as the confidence interval. But how do we express that uncertainty? We know we write it to the correct number of significant figures, so we know that that last digit is uncertain, but how uncertain is it? And we'll first talk about how we can write this out, and then talk about how we can use these uncertainties in calculations. So that'll be sort of the last part of this chapter. So there are three ways, two of them are kind of the same thing, to express uncertainty. One is absolute uncertainty. Say we had our ruler and we measured our distance from that line that we had. Maybe we're using a tape measure. And we measure, say, something that's 97.54 centimeters. Well, we can say, well, that number is good to plus or minus 0.02 centimeters. This would be an example of an absolute uncertainty. We basically do exactly what this plus or minus shows. We can add or subtract 0.02 from our number, and that's the range that we would expect our true value to lie within, our actual measurement. So this is a shorthand for saying it's between 97.52 to 97.56 centimeters. So somewhere in that range is our actual measurement. Okay, and so that's pretty straightforward, and that's a very common way to express uncertainty. Sometimes it's easier, though, to express things as a relative uncertainty. How uncertain is the value, relative to how big it is? And this is basically it's a fraction of the absolute uncertainty. So that would be our 0.02 in the previous example, divided by the value of the measurement. All right, and you could even say, it's an absolute value here, because really it doesn't matter whether it's positive or negative. Sometimes we'll measure things that are negative. It's just the fraction here that matters, not whether it's plus or minus. Okay, and so this will give us a fraction that tells us how big is the uncertainty, compared to the value itself. So if we do this with our example measurement here, 0.02 centimeters divided by 97.54 centimeters. One thing you'll notice is that the centimeters will cancel out. So relative uncertainties do not have units, whereas absolute uncertainties do have units. They have the units of whatever quantity we've measured. Relative uncertainties are a fraction, and so those units cancel out. And we get 0.0002. So that's saying that, the uncertainty is 0.0002 times the value that we measured. A percent relative uncertainty is basically the same as a relative uncertainty, but we write it as a percentage instead of just a fraction. So your textbook really likes to use percent relative uncertainties. I find relative uncertainties to be more straightforward because then you don't have to remember to multiply by 100%. But just write as a percent. So basically you just take the relative uncertainty times 100%. So for this example, we get 0.02%. So that means that there is, our uncertainty is plus or minus 0.02%. And so that's how we would write out this uncertainty for this value.